All right, so we have 4 times 14, and we're going to use the box method to solve this right here. So with the box method, we decompose multi-digit numbers by place value. So in other words, that 14 is the same thing as 10 plus 4. Okay, so 14 is the same thing as 10 and 4 together, still makes 14. So to find the area of this larger box, we're going to multiply 4 times 10, and that's going to give me 40. To find the area of this smaller box, we're going to do 4 times 4, and that's going to give me 16. You'll notice that the numbers that we are multiplying are lined up with each of those sections. Now we can look at an area model to see how it's similar to the box method. Right here I have 4 rows of 14. And now in both of these models, I have the 14 decomposed into 10 and 4. So now if we wanted to find all of these red color squares, the total number, well, there's 4 rows of 10. So that would be 4 times 10, which is exactly what we did over here in the box method. And then for this yellow section, we would do 4 times 4 because we have 4 rows of 4, which is exactly, again, what we did over here in the box method. So you see why the box method works, because we're really just doing 4 times 14 in smaller parts. Now that we know the total for each of these smaller sections, we're going to add these partial products together. Okay, these are called partial products because they're part of the whole product that we're trying to solve for. The whole product would be this whole section, but we need to combine these two partial products to get it. 40 plus 10 is 50, plus 6 more is 56. So 4 times 14 is 56. This time we're going to do the box method with a 3-digit number, and we're going to model with base 10 blocks to show how it makes sense. So with our box method, I know I'm going to be multiplying by 5, but now the 248 I need to decompose. The 2 is in the hundreds place, that's worth 200. The 4 is in the tens place, that's worth 40. The 8 is in the ones place, so it's just 8. So now I can multiply to find the area of each of these sections one step at a time. But before we do that, I want to model 5 groups of 248. My base 10 blocks show 5 times 248 because I have 5 groups of the number 248. Let's look at how they're similar. With the base 10 blocks, I see that I have 5 groups of the number 200. If I'm looking at just the flats, I see I have 200, another 200, another 200, another 200, another 200. That's 5 groups of 200, which is 5 times 200. So in our box method, it makes sense that we're multiplying 5 times 200, which equals 1,000. Next, I notice that I have 5 groups of 40, or 5 times 40. And so I could solve 5 times 40 to figure out how many tens there are. It makes sense that we're doing 5 times 40 to find this section right here. Now to solve 5 times 40, I know 5 times 4 is 20, which means 5 times 40 is 200 because it's 10 times greater. Last but not least, I see that I have 5 groups of the 8 ones, so that's just 5 times 8, which is just 40. So now I just need to combine all of these partial products together in order to solve for the total answer. 1,000 plus 200 is 1,200, plus the 40 is 1,240.